Okay, I'm starting with lecture 12, right? So yesterday we have done the alternating series and we have done the proof of that Leibniz theorem. Is what? If the alternating series, which alternating series? Which we generally notate summation n runs from 1 to infinity minus 1 raised to power n plus 1 un, right? Satisfies the three conditions, right? Right. If a given alternating series has these three blessings, you know those blessings, right? Un should be positive, un should be decreasing, and limit n tends to infinity, un should be 0. Then three conditions for all n greater than equal to some number, say n, right? And we know that how we write it Sn, that means sequence of partial sums. So that is the nth term of sequence of partial sums, or in other words, sum of n terms, right? That's the the simplest thing we can say. Let me write it properly over here. So minus 1 raised to power n plus 1 un. Okay, so this Sn approximates the sum S of the series with an error whose absolute value is less than un plus 1. The numerical value of first unused term, right? So I'm marking these important things. First unused term, right? So absolute value of what? Error. If we approximate what? If we approximate S with which series? Of this series, with Sn, right? So that would be the error. So I hope तुम्हें कुछ ज़्यादा समझ नहीं आया होगा. हाँ, am I right?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Let me start with a very simple example. Then you'll come to know that what this statement says. Okay, we'll do the proof later. So what I'm trying to say is, let's say you have a series GP. Let's don't go for the go for the alternating series. So let's say you have this. Okay. Right. Now this is simple. You know its sum, right? Its sum is what? 1 upon 1 minus half. That's what? 2. But let's say you take only first term and you want to approximate the sum S1. So your first term is what? 1. Now you take first two terms, sum of first two terms. That will become what? 1 plus half, 3 by 2. Let's say you take the sum of first three terms. So that means 3 by 2 plus 1 by 4. That becomes 7 by 4. Right? Is it okay? Now, this is your actual S, and this is the sum of finitely many terms. Now, if you see the difference of S and S1, and you take the modulus of that, that becomes what? 1. You take the difference of these two. Okay?
Yes, sir.
Now you take the difference of S and S2. What is that difference? Can you tell me?
1 by 2.
Yeah. S and S2 having difference 1 by 2. And what is the difference of S and S3?
1 by 4.
3 by 4.
1 by 4.
1 by 4.
1 by 4. So you see that this difference will keep on decreasing.
Yes, sir.
right?
Yes,
Yes,
sir.
sir.
So why is it so? Why is it?
Sir,
कम
we are
increase कर रहा
approaching
ना
to
सर.
2.
series is decreasing.
सम तो increase कर.
Exactly. देखो हमारे पास एक्चुअल सम 2 है, पॉजिटिव टर्म्स हैं, सो वील कीप ऑन इंक्रीजिंग आवर टर्म्स, तो हम एक्चुअल सम के क्लोज आते चले जाएंगे ना,
Yes, sir.
राइट? तो जो अगर
Yes,
जहां
sir.
जो गैप पड़ रहा है, इन गैप्स में these gaps are what? Nothing but we call it as error. This is the error ना, with respect to the actual sum, right? समझ में आ रही है मेरी बात?
Yes, sir.
Sir.
Everyone is getting? Now you come back to the statement again. So what it says that अगर तुम alternating series लो जो 3 conditions पूरी कर रही हैं, 3 conditions पूरी करेंगी, तो इसका मतलब series क्या हो जाएगी? Convergent हो जाएगी ना? इसका मतलब तुम एक convergent series लोगे, कौन सी? Alternating. ठीक है? फिर बोल रहा है तुम SN लो, जैसे हमने यहाँ पे S1, S2, S3 लिया ना, तो बोल रहा है तुम SN लो, और अगर तुम्हें पता हो कि एक्चुअल सम S है, तो ये बोलना ये चाह रहा है कि S और SN का जो एरर है वो UN+1 से ज्यादा नहीं आ सकता. क्या बोल रहा है? Which approximates the sum S of the series with an error. कितना एरर? Whose absolute value is less than UN+1. किससे कम होगी? UN+1 से. That means the difference between the actual sum, right, and nth sum, nth partial sum, इन दोनों का डिफरेंस किससे ज्यादा नहीं हो सकता? UN+1 से. और UN+1 क्या है? फर्स्ट अनयूज्ड टर्म. मींस अगर हमने S3 तक चले तो पहली अनयूज्ड टर्म कौन सी आ जाएगी?
S4.
T4, not S4, T4, right? So that error cannot be less than. That means ये कहने का मतलब ये है कि नॉर्मली इन कंडीशंस में हम ये नहीं पता कर सकते कि मैक्सिमम एरर कितना जाएगा, लेकिन अगर हमारे पास ऑल्टरनेटिंग सीरीज हो, इफ वी आर वर्किंग विद द ऑल्टरनेटिंग सीरीज, देन वी ऑलवेज नो दैट कि the error will have a maximum value, and that maximum value cannot be more than the next term of Sn, right? Actually the next term of this, I would say that the sum of the n terms, and it cannot go beyond the numerical value or actual value or positive value of UN+1, right? So you don't consider the sign first. Okay, that's what I want to prove. Is it fine? Are you getting the statement?
Yes, sir.
इससे पहले कोई एक पहले ये बताओ जिसको स्टेटमेंट ना समझ आई हो, क्योंकि बिफोर, इफ यू आर नॉट अंडरस्टैंडिंग द स्टेटमेंट, आई विल नॉट गो टू द प्रूफ. You write each piece of this, you read each piece of the statement, and then ask me if you are not getting anything.
So approximates मतलब?
अप्रोक्सीमेट का मतलब यही हो गया ना कि एक्चुअल S तो आएगा नहीं हमारे पास, तो SN क्या होगी? अप्रोक्सीमेशन ही होगी ना. जैसे ये क्या है? S1, S2, S3 क्या है? अप्रोक्सीमेशन ही है ना, राइट? ओके.
सर फर्स्ट अनयूज्ड टर्म बता दीजिए एक बार, रिपीट
ओके. अनयूज्ड टर्म का मतलब ये हो गया, जैसे S और S1 है, S और S2 ले लो. S2 में हमने कितनी टर्म्स यूज करी हैं? हाउ मेनी टर्म्स वी हैव यूज्ड इन S2?
2 terms.
2 terms, right? So what is the first unused term then?
1.
U3.
Yeah, U3 ऐसा. S3 में कितनी टर्म्स यूज करी? How many terms we have used in S3?
3 terms.
So what is the first unused term?
U4.
U4.
You got the point now?
Yes.
Yes,
So
sir.
that's why we are saying that if we have used n terms in this sum in order to approximate the S, then error cannot be more than UN+1. That is the first unused term. Okay?
Okay, sir.
So keep in mind, this is not the actual reflection. Why? Because I'm using the positive term series. So this result hold only when we are using the alternating series. Is it fine?
Yes, sir.
Okay, sir.
Is it okay?
Sir,
Yes, sir.
Yes,
Okay.
sir.
सर अब इसमें एरर क्यों बोल रहे हैं?
देखो, एक्चुअल सम और अप्रोक्सीमेशन का जो गैप होगा उसे एरर ही कहा जाएगा ना.
ओके, ठीक है
Right?
सर.
और एरर always remember that, you know, the error cannot be a negative quantity. If we are considering the error, that means we are always taking the absolute value, the absolute value of the difference of actual value and the approximated value.
ओके सर.
Okay, so whenever I
Okay,
talk
sir.
about error, you should keep in mind that I'm always talking about an absolute value, right?
Okay, sir.
So are you with me on this?
Yes, sir.
Yes, so.
So
Yes.
should we move?
Yes,
Yes,
sir.
sir.
Okay. So should I delete this example? We don't need that right now, or should I keep it?
Keep that
रख लो, एक बार
example.
हो
That.
सकता दोबारा पढ़ेंगे तो समझ
Okay,
आएगा.
okay. Let's keep it. Okay. So let's start the proof of that. So we have a series which is already convergent, right? So actually, since the series n runs from 1 to infinity minus 1 raised to power n plus 1 un satisfies all three conditions of Leibniz test. Therefore, summation n runs from infinity minus 1 n plus 1 into un is what? Convergent. This is given to us kind of, right? Okay.
Yes,
Also,
sir.
summation n runs from 1 to infinity minus 1 raised to power n plus 1 un is s. This is given to us. Okay. So this is given to us that let's say the actual sum is s, right?
Yes, sir.
Okay. So let's move to the next part. So if you have Sn this, so your Sn is u1 minus u2 plus u3 minus u4. This is the kind of same expression which we have written yesterday.
Yes, sir.
Okay, so this is your Sn. Now what we're gonna do, again we're gonna do the same thing. One time we'll take the odd number of terms, then we'll take the even number of terms. So first of all, I take, let n is odd. Why I am taking these two cases, that I'll discuss in the last section of the proof. So let's say n is odd. That means we are taking odd terms in the sum. Let's say 2k plus 1. So what would be our 2k plus 1? So n runs from 1 to 2k plus 1. So this will become u1 minus u2 plus u3 minus u4 plus so on, u2k minus u2k plus 1. Okay. Is it okay? Right.
Yes,
Yes,
sir.
sir.
Yes, sir.
So now your um is greater than equal to um plus 1. Why is it so? Why is it so?
Sir, given है. Already given.
Decreasing.
Decreases.
Right. So this is positive. This each bracket is positive.
Yes, sir.
Right. This is also positive.
Yes, sir.
Right.
Yes.
So as we have done in the last lecture. So therefore your S2K plus 1 is increasing. Right?
Yes, sir.
I'm writing a bit wrong thing over here. Actually ये तुमने ना
U2 के नेगेटिव
हाँ मैं आ रहा हूँ, अभी आ रहा हूँ, मैं थोड़ा सा गलत कर गया हूँ, मेरे को लग रहा है ये. तो इट शुड बी लाइक यहाँ U1 है, तो यहाँ U3 है, यहाँ U2K है ना, तो ये थोड़ा गड़बड़ होगा. ये हमें S2K लेना चाहिए, है ना,
माइनस U2K.
2K लेना चाहिए एक्चुअली. इवन वाली ही कल आ रही थी ना इंक्रीजिंग.
यस सर.
तो हाँ, तो 2K लेना चाहिए यहाँ पे. ओके, सो लेट्स स्टार्ट विद even one. U2K minus 1 minus U2K, right? So our S2K is थोड़ी गड़बड़ हो गई है. Okay, so anyways, S2K is increasing. Okay, your S2K is increasing, but you know that S2K is also bounded above by S. Convergence से ज़्यादा तो नहीं जा सकती ना?
Yes, sir.
क्यों? Because this is actual sum, so has to be bounded above by s,
एक्सक्यूज मी सर
है ना? बोलो बोलो.
सर अगर हमने
n is
n
even.
और
n is even. Sorry. Yeah. Okay. Okay. True.
यस सर
Okay. So next is your n is your 2k. So that's fine. Okay. So this is your s2k, which is bounded above by s. Now you take n is equal to 2k plus 1. See what will gonna happen. S2k plus 1. Summation n runs from 1 to 2k plus 1, right? And minus 1 raised to power, I again forgot over here. Okay. So n plus 1 un, right? So that would be something like, if I start u1 minus u2 plus u3 minus u4 plus so on. लास्ट में क्या हो जाएगा हमारे पास? s u2k minus 2 2k minus 1 minus u2k, okay, and the last thing would be minus u2k minus u2k plus 1 plus u2k plus 1. Okay, is it fine? सही बात है?
Yes,
यस
sir.
सर
ठीक है ना? क्योंकि इससे एक फालतू टर्म ही तो आएगी ना, इससे एक टर्म फालतू ही तो आएगी. ये 2k है और यहाँ पे एक टर्म एक्स्ट्रा आ जाएगी, u2k plus 1. That's it, right? Is it fine?
Yes, sir.
Okay, now I'm rewriting it as s2k plus 1. I'll keep this u1 here minus, I'll write it as this. That means u2 minus u3. Okay, then again u4 and u5 minus u4 minus u5 minus, chalte chalte minus, and last will be this and this. That means u2k minus u2k minus 1.
Yes.
Okay. Now can you tell me, is this a positive bracket?
So 2k plus 1.
2k plus 1
Plus 1.
Okay, sorry, 2k plus 1. Yes. Is it a positive bracket?
Yes,
Right?
sir.
yes sir yes sir
All the brackets are positive. So if you make s 2k plus 3 two terms extra, why? Because we are dealing with the odd sequences. Okay, so I'm not taking s2k plus 2, I'm directly taking s2k plus 3. So you will have one more bracket over here which is gonna be negative, right? So you're gonna write it as s2k plus 1 minus, here you're gonna have s2k plus 2 minus 2k plus 3, right? So there is one more bracket which is positive, but outside there is a negative sign. So your s2k plus 3 is less than or equal to your s2k plus 1. Okay?
Yes, sir.
yes
Yes,
Sir.
sir.
So what would I say? Then I say that your s2k plus 1 is what? Decreasing.
Yes, sir.
Yes, sir.
Yes, sir.
Earlier is used to be increasing, now it is decreasing. But again, क्योंकि convergent है, so it cannot go beyond s, right? So s2k plus 1 is always greater than equal to s. लिमिट से बाहर तो जा ही नहीं सकती. तो अब दो चीजें हो गई तुम्हारे पास. Keep in mind, पहली चीज, I'll mark this star, कि this is increasing. Let me take it over here. Yes. So yeah, so I'll keep this as star and I'll keep this thing as double star, this thing. Okay, so now you have two things. Now see, अब तुमने बताना है कि ये है, what do you want to say? This is your actual sum and this is the sum of n terms, यही है ना? And this whole quantity is what? Error. Now what do you want to say? That the error is always less than equal to un plus 1,
Yes, sir.
right? Okay, now we have two cases. Case 1, n can be even. Case 2, n can be odd. So let's say case 1, right? So if you case 1, your n is odd or even. We have treated the even case. Let's say n is even. So if your n is even, so your Sn is, we have proved na, when your n is even, then your Sn is always less than equal to S, right? ये प्रूव किया ना हमने यहाँ पे, अगर even हो तो, हाँ?
Sir.
Yes, sir.
Yes,
If
sir.
your n is even, then n plus 1 क्या होगा? Is odd.
Yes, sir.
और odd
Yes,
के
sir.
केस में हमने क्या प्रूव किया है कि Sn plus 1 is greater than equal to S.
Yes.
यही किया ना यहाँ पे, क्योंकि इसमें डिक्रीजिंग है ना, राइट? इफ योर n इज इवन तो इंक्रीजिंग है, एंड n प्लस 1 डिक्रीजिंग है, तो यहाँ पे दो केसेस हो गए ना. ये कहां से आए हैं दोनों केसेस? बाय स्टार एंड डबल स्टार. ओके ओके,
Yes,
right?
sir.
So now you consider S minus Sn. So since S minus Sn is greater than equal to 0, n हमारा even है, तो यहां से हमने ये चीज निकाली और यहां से ये चीज है, S minus Sn is greater than equal to 0. So मॉडुलस पे कोई साइन का फर्क नहीं पड़ेगा ना, मॉडुलस would be as it is. Why? Because it is a positive quantity, है ना?
Yes, sir.
Yes.
Right? Okay, so further it is less than equal to Sn plus 1 minus Sn. Why? Because your Sn plus 1 is greater than S. Okay,
Yes.
so here you are replacing with a bigger quantity. Bigger quantity, na?
Yes, sir.
So if your quantity is bigger, that means your positive quantity is bigger. So this difference is gonna be bigger. Okay.
Yes, sir.
Yes,
And what
sir.
is the difference of Sn plus 1 minus Sn? Un plus 1, right?
Yes, sir.
यही होगा ना. So इस
Yes,
केस
sir.
में हमने प्रूव कर दिया कि S minus Sn is always less than equal to Un plus 1. अब मान लेते हैं केस 2, ये भी आसान है. केस 2, if your n is odd, right? So if your n is odd, you know that by this double star, your Sn is a decreasing, right? True? So then your Sn is decreasing. So therefore Sn is greater than equal to S, right? ये decreasing वाला word लिखने की वैसे कोई जरूरत ही नहीं है, पीछे हम प्रूव कर चुके हैं. We have already proved that. Don't need to mention this. Okay. So, and if your n is odd, then n plus 1 is what? Is even. Okay. And in that case, your Sn plus 1 will be less than equal to S. Right? Why? Again, I'm using by star and double star. True? Now, what we gonna calculate? We're gonna get the difference of Sn plus 1 minus, we're gonna calculate the difference of S minus Sn. Okay, but from here you see that S minus Sn is less than equal to 0. Okay,
Yes, sir.
Sure.
तो मॉड में लिखने के लिए तुम्हें माइनस S minus Sn करना पड़ेगा ऐसे,
Yes.
तभी पॉजिटिव होगा ना, क्योंकि नेगेटिव है. सो यू नीड टू पुट अ नेगेटिव साइन ओवर देयर सो दैट इट बिकम्स पॉजिटिव, राइट? यू वांट टू श्योर दैट इट शुड बी अ पॉजिटिव वैल्यू. मॉडुलस का मतलब ही क्या है? पॉजिटिव ही करना है ना. नेगेटिव क्वांटिटी हो तो नेगेटिव से मल्टीप्लाई करना पड़ेगा. सो दिस कैन बी रिटन एज Sn minus S, राइट? नाउ योर S is less than equal to Sn plus 1. So this can be further written as S minus Sn plus 1. Why? Because you know that your S is greater than equal to, or I would say that Sn plus 1 is less than equal to S. देखो यहाँ छोटी क्वांटिटी से रिप्लेस कर दिया. You have replaced with the smaller quantities. तो पहले मान लो जैसे था 10 minus 4. अब अगर यहाँ छोटी क्वांटिटी रख दोगे 10 minus 2, तो ये क्वांटिटी बड़ी हो जाएगी ना. ये 8 बननी थी, ये 6 बननी थी. समझ आ गई मेरी बात? Right? So you are subtracting a smaller quantity. That means your difference is gonna be bigger. Okay? Is it okay?
Yes, sir.
Okay. So let's see. So now this is what? Again, Sn minus Sn plus 1 is what? Un plus 1. आना नेगेटिव में है, लेकिन हमने तो पॉजिटिव ही लेना ना, हमने तो मॉडुलस वाली वैल्यू लेनी है. So therefore, S minus Sn is again less than equal to Un plus 1. So I've proved both the cases. If your n is even then you'll get the modulus is less than equal to Un plus 1. And if your n is odd, even then you'll take the modulus is less than equal to Un plus 1. Right? Is it fine?
Yes, sir.
So
Yes,
have you
sir.
proved the thing?
Yes.
You're getting
Yes,
the
sir.
point?
Yes, sir.
Okay. So let's say do few examples. Okay. So let me check some questions from the exercise, so this is a separate part over here. That is question number 45 to 48. All the questions are for the error. All you need to find out the errors, right? Can you see this? Do you have books right now?
Yes, sir.
No.
Okay, if somebody has, you directly go to the question number 45 to 47. You will get that. You will get to know that we have the errors over there. Okay, error part is over there. Okay, so let's start. So let's say few examples. Let's say some questions. Suppose we have question number 45. Okay, question number 45 में क्या कहा क्या गया है? Can anybody tell me? So this is our series, right? And what is said? Now, given that, however, it's a standard series, we didn't prove like that way, but its sum is log 2. Maybe we'll prove sometime, okay? So its sum is log 2. So you have actual S, that is log 2. So question, what he's asking is, find the error when you calculate the sum, when you approximate the sum of using first 4 terms. Using first 4 terms. Okay, so you know that what could be the error? Can you tell me what is the maximum value of the error? Find the maximum value of error. क्या होगी? क्या होगी? बताओ. Theorem से बताओ क्या होगी? Maximum value of error. Can anybody tell me?
1 plus 1.
1 by 5.
Log
1 upon 5.
4.
1 by 5.
Fifth term, that's it. Maximum value क्या बन सकती है? Fifth term, है ना?
Yes.
So
Yes, sir.
you know that your error in this case, right? What is your error? This is your error, S minus S4, and this is always less than equal to the T5. Okay, so we'll need to take the modulus of the fifth term. Okay, so minus 1, you put n is equal to 5 over here, 5 plus 1, 1 by 5. So that's what? Tell me, what is that?
1 by 5.
0.2. Okay, so this is the maximum value of the error, right?
Yes,
Are
sir.
you getting this?
So is it given that
Yes,
S
sir.
is equal to log 2 using
Yeah.
first 4 term?
नहीं एक्चुअली वो ब्रैकेट में दिया हुआ है कि एरर इससे ज्यादा नहीं हो सकता. ओके, और कोई खास बात नहीं है, जस्ट इसमें दिया हुआ है कि इससे ज्यादा एरर नहीं हो सकता, राइट? तो अदरवाइज हमें एस की कोई जरूरत नहीं है, बिकॉज वी नो दैट यही सबसे बड़ी, देखो ये क्वेश्चन प्रूव करने का, ये थ्योरम प्रूव करने का सबसे बड़ा बेनिफिट क्या है? कैन यू टेल मी अ बेनिफिट? Can anybody tell me the benefit?
We can find upper bound.
That is true. That's what we are doing. That means this result is independent of finding the S. We don't need the S at all. Okay? So we don't need the actual sum. We can directly tell that this amount of error can happen. Maximum amount of the error is UN plus 1 without knowing the actual value of S. Okay? So we don't need log 2 at all. That is just the part of the statement. Okay? Are you getting this?
Yes, sir.
Yes, sir.
Yes, sir.
Have we used S? No, we don't need it. Why? Because we know that it is gonna be always less than equal to T5, right? हाँ, exactly T5 नहीं होगा, लेकिन T5 के बराबर हो सकता है, T5 से ज़्यादा नहीं हो सकता. The error cannot be more than this. Okay. So now, sometimes you can find the error, actual error. Sometimes you don't. So in such cases, when you are not able to get the actual value of the error, so you can always tell a rough bound that error cannot go beyond this, right? So let's say next question. Question number, say 46. Now, sometimes, as I've told you, you can tell the error. So again, we're gonna use the first 4 terms. So can you tell me what is the error which can we have over here, maximum value of the error?
1 by 10 raised to power 5.
1 upon 10 raised to the power 5.
Yes. 5 plus 1, 1 by 10 raised to power 5, which is 1 by, this is the maximum amount of the error. Okay, but now can you find the actual value of this sum? Can you find it or not?
Yes, sir.
Guru?
Yes,
How
sir.
you can find it?
Yes, sir.
By
Yes, sir,
replacing
ये
S4.
GP है, yes,
GP
that's
है.
what it is. ये आसान है, ये GP है, right? So here you have a better information. You can find the actual value of the error. But sometimes in these cases, suppose you don't know that it is equal to log 2, then you are not able to find the actual value of the error. But here you can find the actual value of error as well. Okay.
Yes, sir.
Okay. So, I'll leave 2 questions for you, question number 47 and question number 48. Okay. Now, I'll give you one tricky example over here. You need to construct that example. Can you tell me this? And if you can tell me this, I would say that you have learned quite a lot. So this is question number 58, last question of our lecture. That's what. Show by example that summation n runs from 1 to infinity a and bn may diverge even if summation an and summation bn both converge. Yes. है कोई जवाब? जिसको इसका जवाब आता है समझ लो बहुत कुछ आता है उसे.
Sir, n or 1 upon n square.
N and 1 by n square. So your 1 by n square is convergent, right?
n
So
convergent नहीं है ना?
but we know we are saying that both convergent. तो divergent है ना?
Yes, sir.
ये क्वेश्चन गलत है.
No, sir.
तुम्हें कैसे पता गलत है? तुमने तो पढ़ा ही है 2 की डाइवर्जेंट की प्रोडक्ट कन्वर्जेंट की प्रोडक्ट कन्वर्जेंट ही होती है.
सर कोई एक्सेप्शन हो सकती है.
Exactly, that's right. But what is that exception?
1 by root 2.
See, this is when you are learning sequence and series, it's just like a movie. You need to know the strength of each character. Only then you'll able to interpolate what is gonna happen. मैंने कहीं भी an bn पॉजिटिव नहीं कहा. ओके तो जो मैंने रिजल्ट पिछले करवाए थे, they are valid only when your ans and bns are positive. Now you see this. Let's say you take the an minus 1 raised to power n over root n, and you take the bn as well minus 1 raised to power
Yes,
n.
sir. Yes.
Are both are convergent?
Yes, sir.
Yes,
Both
sir.
are convergent?
Yes, sir.
Yes, sir.
No.
Yes.
I would say that now tell me, both are convergent? Because we are talking about series.
Yes, sir. Now they converge.
Yes, sir.
By which result?
Alternating series.
Alternating.
Yes.
Leibniz test.
Yes.
Leibniz
Leibniz is only our true friend in the times of alternating series, right? All
Yes,
other
sir.
tests are like cheaters. They just leave us. Okay. only Leibniz will help us.
Yes, sir.
Right?
But 1 by n is divergent, sir. 1 by n.
Yes. Now, if you take
Effect
A
product.
and Bn, if you take A and Bn, then your minus will turn out to be positive, and your root n and root n will become n.
N.
So now by p-test it is what? Divergent.
Divergent, sir. Divergent.
An interesting question.
Yes.
Yes, sir.
Yes, sir.
ये interesting question will give you only one message. वही, don't underestimate the power of A n positive, B n positive. Okay?
Yes, sir.
समझ गए?
सर अब और भी एग्जांपल्स हो सकते हैं जिसमें ए एन बी एन नेगेटिव लेके
हाँ हाँ हाँ, there are so many examples. You can construct in a way ना कि देखो तुमने डाइवर्जेंट बनाना है, ठीक है, तो यहाँ की पावर जो है वो एक से छोटी या एक के बराबर रहनी चाहिए. ऐसे कोई मर्जी एग्जांपल बना लो, सारे बन जाएंगे, है ना. एक से छोटी पावर अल्टरनेटिंग में ही कन्वर्जेंट हो सकती है, पॉजिटिव में हो ही नहीं सकती.
अगर हम उसके अंदर कुछ मतलब ऐड कर देते हैं लाइक 2 और 3 तब भी तो ठीक है.
हाँ, it doesn't make any difference if you add something. It doesn't make any difference, but here it will make some difference. Actual sum में 2 करते हो तो कोई दिक्कत नहीं है. यहाँ क्या प्रॉब्लम होगी? If you add some, let's say you add 2, what will happen?
नहीं सर, रूट n के अंदर सर नीचे से.
That will work. That will work.
Yes, sir.
That will work.
Yes, sir.
Yeah, that will work. So these are the small variations you can perform, right?
Yes, sir.
I'm just, I've just constructed a very simple example. You may leave now if you want, anyone. If you have some doubt, you can ask. Otherwise, you may leave.
Thank you, sir.
Okay.